Starting Advent of Code Day 4 in F#. I'll be honest, I read this while I was eating breakfast, but I'll go through it again. Gondola takes you up and strangely doesn't come with you as well. Much warmer than it is. It's just a shame. I like how they link to a definition of a scratchboard. Interesting. Okay, so they give us a puzzle input. Here we go. Which of the numbers you have appear on the list of winning numbers? The first match. Okay, so we got two sets of numbers, and we just look for matches. In the example above, card 1 has 5 winning numbers, 41, and 8 numbers you have. So the first 4 are the numbers, or before the bar at least, are the first numbers. Or the winning numbers, and here are the numbers I have. Got it. And then it's just choose power. Okay, that seems pretty simple. I'll grab that sample input because I'll definitely need that. Let's make day 4. Day 4.fs. Alright, so let's paste this sample in. Alright, so we have our sample. Let's parse it. So I'm going to parse this into, I want to return 2 sets. I think it's all like a sequence of, so we'll take the line to the input, and for each line, let's say parse line is equal to parse line, and then that's it. So we're just going to return that. So, okay, so to parse the line, let's I think make this its own function. Let's make a regex of card. I don't really care what the card number is. And then, oh, actually, I don't even need to do. Okay, we'll do this fine. We'll say line. Nums is line, which is a string. I'll split on that bar, or I'll split on colons first, and take the 1th element to get the right side, because I don't really need the number. I think I can do this. Left, right is equal to. I don't know if I can do this. Nums.split on this. Yeah, I don't think I can do it. But I can definitely do this in match expression. So I could do match this with, and if it's an array of left, right, then I can do something with it. And if it's otherwise, then it doesn't really matter. It could just raise an exception. Bad input. Okay, so once I'm in here and I have the left and right, I just need to split on spaces, I think. I'll return a tuple of, to the left is the winning number, so left split on spaces, pass that into int parsing function, and the same with the right. I guess I'll have to. Seek that map. And then I actually want to turn this into a set for both of them. Set.of seek. Okay, so this will return a hash set of the numbers on the left and right for each one. Okay, so I have my input parsed. I have my sample. So to solve A, I think all I need to do is let the left and right, or no, sorry, not left and right. Well, so parse the input, and then, oh, I need a scoring function. Here we go. Let's score left, right. You know, I'll take this one as a tuple. Let's score on the left and right, which are both sets of ints, which I can annotate. Set int and which is a set int. I don't know how you do set. Set. Okay. So given two sets, the score is set.intersect left, right? And then raise 2 to the seek.length of matches. That's an int. Feels reasonable to me. Because 2 to 1 match would be 2. Oh, so I guess this is the length of matches minus 1, I think. Length of matches minus 1. Does it complain with that? Sure. Is that right? I don't know. Okay, so anyway, so this will be, if there's one match, it'll be 0, so 2 to 0 is 1, 2 should be 2, 4. Okay, cool. So, parse the input, score the input, sum that. Is it sum? I don't know. Sorry, let me get my tabs in there. There we go. Yeah, so it's 8, 2, 2. Okay, so. And then turn this into a string. Okay, that looks pretty reasonable to me. So test A will take in the sample and it will produce 13 and solve A on X. Cool, didn't work. Let's see. Input incorrect format. Oh, I was wondering this. When I convert them to ints here, where is that? Yeah. There's like a split options in C# that ignores empty. Yeah. Split. do this? Let's see. F sharp, split string, ignore, empty. I mean, I could always just do this manually, but. On an F sharp. F sharp, F sharp, F sharp. Oh, there we go. I see. It's Alright, let's see if this fixes it. If not, I can do this with the right guy. I just didn't really want to. Cool, passes. Awesome. So let's get the input. Close out of that. I get my puzzle input. Copy that. Go back over here. Day04.text. Cool. Plot it in, hard code it. I'm gonna run the last. Cool. Hopefully that's the right number. Let's check. Oops. Okay, gold star. Awesome. It's the quickest first gold star I've had so far. The rules have been actually printed on the board. Okay. There's no such thing as points. Instead, they only cause you to win more scratch cards equal to the number of winning card you have. Specifically, you win copies of the scratch card below the winning card equal to the number of matches. So card 10 were to have 5 matching numbers, you would win 1 copy each of cards 11. Okay. Copies of scratch cards are scored like normal. Scratch cards have the same card number. That probably means I need the card number. Well, I guess I'll get it from just indexing the array. Okay, whatever. If you win a copy of a card 10 and has 5 matching numbers, it would. Copies of the scratch cards are scored like normal. So definitely going to need some dynamic programming so you don't recompute the wins, though that's really efficient to compute wins anyway. No, but I guess it stops you from being like circular. Yeah, because you just don't want to like have to. Right, you're not going to want to traverse that whole tree again. Okay. So I feel like definitely the trick is going to be not to recompute the tree. So So it's almost like a depth first search from that first card. And then if any, so let me think for a second. So if you have, let's say it's a dictionary and you have like, let's say at index 3, you generate card 4 and 5. And at index 4, you generate 5 and 6. Or, yeah, sure, if you generate 5 and 6. I feel like you should then also add it back to this one. And that way next time you generate card 3, you just increment that tally immediately. Because then every time you see 3, is that right? That wins 3. Yeah, because if 3 wins 4, and every time you win 3, you win 5 and 6 as well. I think that sounds right. So if I win 3, I win 4 and 5. I compute 4, I get 5 and 6. Which meant when I won 3, I would win 4, 5, and 5, 6. Yes, I think every time I see a number, I should return all the numbers it implies. That's what I should do as a sequence. Okay, so I'll call this tree score. So imagine I have, gonna need a dictionary, so a state dictionary, which let's say it's a map of integer to, I guess, sequence of integers. And it's going to take in so a card is, there's going to be something interesting about yeah, we're going to need to add, okay, this is fine. Okay, this will be fine. So that's the state. And then it's going to take in a sequence of well, our cards, which are sequences of int. Sorry, this should be a lowercase c. Sorry, and this will be the cards, which are a sequence of ints, and then another sequence of ints, so left and right. Okay. I might take this in for loop actually. I think that's gonna be good. So for card. Actually, no, well, maybe. I'll just return 1 for now. Okay, so let tree score card. So let's imagine we work on one card at a time again, because I think that's easier. So same input. I'm gonna make this a list, because then I can index into it with numbers. Which will help a little bit. Okay, so interesting. So I need to these aren't seeks. These are. Actually, this one over here is a sequence events because okay. All right. So to score this card, so if I can find the card gnome and it's some number or some seek, then I'm gonna return that sequence. That's all the numbers that it's gonna ever match. Maybe it's really count, but I can do that. I can always unwrap that later. Okay, if it's none, then sorry, this is the width. Then this is where I'm gonna actually need to do my real logic here. So I'm gonna need to say the that matches is equal to let matches be the matches of what is it taking down? Cards. Yeah, this should be a list. Of cards, card -1 because I think the cards start at 1. Yeah. Okay, so we get the matching numbers, and we actually just want that like that. So there's 1 match, 2 match, whatever. This will be like then n matches. Copy cards will be the card num to map to card num plus matches. Now all of our F# ranges inclusive. That's what I didn't remember. Including endpoint 1 and 5. So if you do 1 to 5, you get 5 elements. So if I do card 1 to 2, I'll get 2 matches. So 1 plus 1. Okay, cool. So those are the cards I'm going to copy. And so I want to basically let the, that's where I'm going to start mutating the state. So let the copy outputs be copy cards pass through the seek.map of tree, and this needs to be a recursive function, of tree scorecard given the state cards, and then the output is the the copy card is the number that's going to be passed in. We're then going to flatten that. All derivative numbers be the copy card outputs, copy outputs into seek.concat. Then we're going to store that in the state. So state for this card, state.set add card num all derivative card numbers. What's add taken as a parameter? Add. It takes in a tuple, right? Oh no, sorry, it takes in a key. And a value separately. Yeah, it takes in a tuple. So it must be like this. Card num all derivative numbers. Yeah. What does it ignore? You know, I actually want this to be mutable. I'm gonna make this a dictionary. And make this a dictionary. So I really do want mutability here. Try find dictionary F sharp. Mutable map F sharp. I want one of the two of these. Match with no F sharp. How do I match with no or yeah, okay, so I do want, I guess maybe I'll put null on top, maybe that's all I need to do. Cool. So this is the state, cards, and the card number. Why is this component? So the state, the cards, and the card number. Next to tree scorecard on state cards X. Oh, I just cause yeah, that's fine. So we add that derivative number and then we return state to card number. That's fine. Yeah, there you go. That's pretty good. Okay, so I feel like that's good for one card. Hopefully that base case is fine. Because when I hit, let's see, what is the base case? When I hit empty, card outputs will be empty. Because 1 to... Oh, I guess... if match is a 0, I should check here. Match matches with 0, then there are no derivative outputs, so an empty array. I guess what I really should do, sorry. I guess all derivative numbers should be expressions. So I should match matches with 0 to be an empty list, and if it's x, then do that. Try to make a seek.empty. There we go. Okay, that's better. That's the base case. And then 0, just empty. Doesn't continue, otherwise it recurses down. Okay. Neat. What's time box? This is 20 minutes, so 10 after I go to my actual job. That's more fun though. Alright, so cool, so what do I actually have to do? So I think I just need to say for card in cards. So for each card, I'm going to let the outputs be the tree. So I need a dictionary. So var state let state equal a dictionary of integer sequence of ints. And then let's let we have the cards. Indexed. Sorry. Index. So we have the number and the card. Just make sure the type's right. Yeah. But actually the card num is going to be the card plus 1, because this is going to start at 0 and the cards, as we saw, started at 1 equals num plus 1. Okay. So let the outputs be the tree scorecard with the state cards and the card num. Yeah. Nice. Once I have the outputs, what do I want to do with these? So I'm going to assume I got all this right. I think I did. Once you have all the original copies processed, you end up with 1 instance of card 1, 2 instances of card 2, 4 instances of card 3, 30 scratch cards. Just take the sum, I guess. But, well, I can do this functionally, I guess. So if I'm going to do this functionally, then I want to yield the outputs so, okay. So I want to yield the outputs and then just take the sum plus the card amount. So card 1 is equal to card 1 plus all the cards it generates. Okay. Winnings to a string. That doesn't need to take on state. Okay. It compiles. That's good. It's alright. 30 is something. Be cool if this is right. I don't think it will be, but we'll see. Nothing. Oh, solve B, sorry, I didn't even go to the body. Where's solve B? Solve B. We need to parse the input. To be honest, this should really semantically return an int, and then this one can convert it to a string. Okay. Yeah, okay, fine. What does this say? A Stack Overflow exception? Runtime helper is taken here. Oh, sorry, this should be tree score. Oh, it's funny. Do I not ever pass in the... I never actually use the card, I just grabbed it from here. That's interesting. So this has the same number. So if you win a copy of card 10 and it has and have the same number of the card they got, that's no, that's what I expected. Okay. It looks like I want like a debugger to just walk through this recursion properly. This could always be wrong. So the card number. Sorry, this needs to be card number plus 1. Otherwise it's gonna copy itself. Yeah. 6. Okay, cool. But it's not endlessly recursing, which is fantastic. Okay, so let's dump the state at the end of this. Which makes me think that, yeah, let's dump the state. So I'm curious what's in there. Nothing. Okay, so tree scorecard. Let's see what's going on. I'm just gonna make this kind of verbose really quick. So let's dump. There are 4 card matches. Doesn't dump do my JSON dumping? It does. Okay. Nice. When I think I want to return a sequence of I think I need to add the current number. So the current number always needs to be added to the. One second. So. Yeah, I feel like this should always return itself as well. So the card that or something. I don't know that. So in list, I'm not about that. Seek.concat. Oh, is this just need to be semicolon? No. Seek.concat a list of just the card num and and the all derivative numbers. This feels needless. Some seek. I don't know. How to make a seek with one element in it. Oh no, that worked. Okay, cool. Oh, and then I probably need to just return one. Okay, because then it's going to count itself in scoring, which is good because I need to build that. Okay, so. Derivative numbers, I think I need to do this logic up here. Oh, what's the... Oh, sorry, state. Okay. There we go. Much better. Okay, so let's run the rest. Hopefully this doesn't like error out or anything. A little slow, but hopefully the right answer. Yay, it's done. I know I can speed that up, but honestly, it might just be the dumping. One second, let me just. I am building up. I know what I'm doing. One of the issues is I'm building up a huge amount of the tree in memory. Yeah, I mean, I did reduce it by half, so. I wonder if because they're lazy too, I wonder if some of these need to be, like if I did list duck and cut. Or if I turn this into, I'm just curious really quick. Or before I mess around with this, let me just save. Day 4 complete. Oops, there we go, day 4 complete. And we'll sync that. So I'm wondering if the laziness of this is causing some issues. I'm just gonna hack around a little bit really quickly. State is gonna be a list. And then, sorry, we're gonna turn this into list of seek. Oh, list in F# is, shoot. This isn't really a list, this is a resize array event. And then this is a resize array. And then this is a state needs to have a resize array, because that's an array list in normal languages. Is that any better? Yeah, much better, because it's not doing the lazy generation. Okay. Cool. Remove lazy seek. Awesome. That's all. Advent to code, day 4, done. It's probably the cleanest day, I think.